Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of derivatives for exponential functions. So as per the problem, determine the coordinates of all points at which the tangent to the curve defined by y equals x squared times e to the power negative x is horizontal. So we have to find the coordinates of the points at which the tangent is horizontal to this curve. And if a tangent is horizontal, that means its slope is equal to 0. And slope of a tangent can be found by finding the derivative of this given function. So the first step is to find the derivative of this function defined by y equals x squared times e to the power negative x. So m, which is the slope of the tangent, is equal to y prime. Now this given function is made up of two functions being multiplied. One is x squared, the quadratic function, times the exponential function e to the power negative x. So we should use product rule to find its derivative. So as per the product rule, we'll start with the derivative of the first term x squared, and the derivative of x squared as per power rule is 2x times the second term plus the first term x squared times the derivative of the second term e to the power negative x. So its derivative will be the e term as it is given times the derivative of the exponent. Now the exponent of e is negative x, so its derivative will be negative 1. Now we can simplify this expression. So m, the slope of the tangent, is equal to, so in the first part, so 2x times e to the power negative x will just be 2x e to the power negative x. And in the second part, we can multiply x squared by negative 1, so it becomes negative x squared. So we get negative and x squared e to the power negative x. Now we can move the e terms to the denominator to make their exponents positive. So m equals 2x Now we have to find the points at which the tangent is horizontal. That means the slope of the tangent should be equal to 0. So we'll sub in m as 0 in this equation. Now we have to solve this equation. We can simplify this equation by doing common factoring. So we can factor x over e to the power x from both terms. So this is the factored form of this equation. Now we get two cases that we can use to solve this equation. So the first case is x over e to the power x is equal to 0. So we can cross multiply the denominator. So we get x equals 0. So this is the first x value we get at which the tangent is horizontal. Now we can analyze the second case. Now we can isolate x by subtracting 2 from both sides. So we get, now we can change negative x to positive x by dividing both sides by negative 1. So negative on the left side get cancelled out. So we are left with x equals positive 2. So this is the second x coordinate at which the tangent is horizontal. Now we have to find the points. So that means we have to find the corresponding y values for these x values. So we should sub in these x values one by one in the given equation of the curve to find the corresponding y values. So let's start with x equals 0. So we sub in x equals 0 as 0 squared times e exponent negative 0. Now 0 squared is equal to 0, and if we move e to the denominator to make the exponent positive, so we'll get e to the power 0, and we know any term to the power 0 is equal to 1, so 0 over 1, which is equal to 0. So the first point where the tangent is horizontal is 0, comma 0. Now for the second point, we should sub in x as 2 in the given equation. Now we know that 2 square is equal to 4, and we can move e to the denominator to make the exponent positive. So this is the y value for x equals 2. So the second point where the tangent is horizontal is 2 and 4 over e squared. So these are the 2 points on this curve where the tangent is horizontal. So this should be the final answer for this problem. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.